Assalamualaikum warahmatullahi wabarakatuh. Welcome. Today, my Group 3, will be presenting our case study for today, which is engineering solutions for better sustainability and safety in a workshop environment. Now, what is our objective for today? Our objective, firstly, is to assess the current safety measures taken by our workshop to ensure safety and sustainability in its uses. Number 2, it is to explore the current threat and safety and sustainability issues present in our workshop today. Number 3 is to propose different solutions and applications of code. Number 4, it is to evaluate the range of conflicting requirements. Now, come with me to explore the current safety measures taken by our workshop. Now on to our first objective for today is to explore the current safety measures taken by the workshop to ensure sustainability and safety for the students. Now, if you would like to follow me, here's the first way they ensure safety for the students. The first way they do it is they designate a safety spot or a tempat berkumpul when there is an emergency. Now, this can help in many ways, but first and the most important one is by making sure that there is a safe spot the students can go to in case of an emergency. Now, secondly, the way they ensure the safety of the students or the users of the workshop is by making sure there is a dress code. Now, what you see me wearing here right now is the proper dress code to ensure proper safety. This upper top is called a faculty jacket, where you must zip all the way up as well as button fully. To ensure that there is nothing wrong and everything is fully covered. Onto the pants, these must have a rough texture to ensure that no loose metal shavings can burn your pants or put a hole through them. That can help in also other ways, but the most important part of working in a workshop is the steel-toed boots. These boots are to ensure that nothing that falls from workshop or table height can ever hurt your feet. Now, continuing on.
First, let's look at the technical issue, starting with the lack of lathe bed and slide calibration. Because these machines are heavily used by multiple student groups, they experience constant vibration and wear down over time. When calibration is lost, the machine stops cutting accurately and create uneven tapers instead of perfect cylinders. This causes students to fail their practical measurement, leading to ruined project and waste raw material. Another technical issue involves dull, cheap or improperly set cutting tool. When students reuse worn out tool or mount them at the wrong height, the tool cannot slice smoothly. This creates a terrible rough surface finish on the workpiece and force the motor to work much harder, which can break the tool or damage the machine gears. A major safety risk is the flying swath and metal chips hazard. When the lathe casts metal at high speeds, it throws off sharp waste fragments called chips and long curly ribbon called swath. Due to intense friction, the fragments fly off burning hot and razor sharp. Without a transparent safety sheet, this projectile can fly into an operator or bystander eyes, causing permanent blindness or length of basking, causing severe burns and cuts. Finally, our sustainability issue is inefficient energy consumption from idling lathes. This happens when students leave the main motor and coolant pump running while they walk away to look at drawing, ask questions, or measure their workpiece. This idle machinery drains electricity from the grid for no reason, which increases campus utility costs and inflate our carbon footprint. This completely goes against the goal of SDG 12 for responsible construction and production. By identifying this issue, we can see that proper machine maintenance and safety awareness are vital for a sustainable workshop environment. Thank you.
Now, I am proposing a vital transformation for our lab machine, addressing 4 critical technicals, safety, and sustainability issues. To solve these, we propose 4 interconnected sustainable solutions. First, predictive laser calibration. We will implement regular laser alignment routines for lead beds to restore precision and eliminate mechanical strain. And by second, smart tool condition monitoring. We will deploy vibration sensors on tools posts to detect dullness early, optimizing tools life and energy efficiency. And by third, magnetic swath conveyors and telescopic shields. We will install interlock impact resistant guards coupled with automated magnetic conveyors to safely capture and segregate hot chips at the source for recycling. And lastly, automated eco-idle smart switches. We will retrofit LED with smart sensors to automatically transition motors to a low energy standby mode if left idling for more than 2 minutes. These solutions ensure absolute compliance with major frameworks. By developing interlocking guards, we fulfill OSHA requirements for machine guarding, protecting our people from flying hazards. Through the structure risk assessment of MS1722, we systematically eliminate operational errors caused by uncalibrated machinery. Finally, we automated energy switches and swath recycling directly drive compliance with ISO 14001, significantly lowering our carbon footprint and waste. And that's all from me. Now I will pass it to my friend.
In engineering workshops, the challenge of balancing cost, safety, and environmental impact requires thoughtful and responsible decision-making. Cost efficiency is important to keep operations viable, but it cannot come at the expense of worker safety or environmental responsibility. Safety must always be prioritized, even if it increases expenses or slows production, because protecting workers and preventing accidents ensures long-term stability. At the same time, environmental sustainability through practices such as waste reduction, energy efficiency, and responsible material use demands attention as it reflects both regulatory compliance and ethical duty to future generations. When these factors conflict, engineers rely on risk assessment, cost-benefit analysis, and stakeholder consultation to make fair decisions. Incremental improvements like upgrading ventilation system or adopting energy-efficient machinery allow workshops to progress without overwhelming financial strain. Ultimately, responsible engineers strive for solutions that minimize risk and environmental harm while maintaining economic viability. This balanced approach ensures that workshop activities remain safe, sustainable, and ethically sound, embodying the true spirit of engineering as a discipline committed to both progress and responsibility.
In conclusion, optimizing workshop-less operations requires a balanced approach that synthesizes mechanical productivity with ethical engineering practices. Systematic issues such as entanglement risk, toxic mist generation, and hazardous waste cannot be ignored. In the pursuit of component manufacturing, by anchoring workshop operation to the regulatory framework of OSHA 19012 and ISO 14001, organizations establish a compliant and resilient operational baseline. The successful management of modern workshop relies entirely on an engineer's ability to navigate the natural friction between speed and safety. Ultimately, implementing robust engineering controls, adopting sustainable chemical alternatives, and accepting localized threats ensures that the workshop remains highly efficient tools that industrial production without compromising human health or environmental integrity. That's all from us. Thank you.